Okay, Bismillahirrahmanirrahim. Okay, folks, welcome to my lesson here. My student, Amina. We are looking at finding the nth term. Clip 112, grade C Mathswatch CD work. This question not necessarily from that page, but it's similar. We're looking at linear number patterns. Okay, now when we look at a number sequence, what we need to know is what we're talking about when we're talking about the nth term. So first of all, let's label up our term numbers. So this first number here as is called n equals 1. So this is the first term. 13 is the second term, so n equals 2, where n is the term number. And this is n equals 3, and so on. So when we try to work out the nth term, we try to work out a rule for this number sequence so we can generalize what's happening. So if I look from here from 10 to 13, what I find out is that my rule is going up by 3. And 13 to 16 is going up by 3. So we have a consistent increase in our number pattern, number sequence by 3. So when we start to formulate our rule, what do we say? So we're going to have now n refers to the term number, so we can keep that general. So we have, now we're going to go up in multiples of 3. So the answer will have a 3n in there. Okay. Now it will start off with 3n, and then it will have, we could say here it's going to be, that's 3 is actually the difference. So that 3 there is the difference in this case. Let's give that a purple. So we can say that the difference is equal to 3. Also another type of labeling that we have, this is a value. A is the first term, is equal to 10. Now that's very important here, the difference. Okay, that's the first term. Now, quick question. What terms, first term, second term, third term, fourth term, what comes before 1? What number? The answer is 0. We also have a 0 term. So what number would have come before 10 if we carried on going that way? Okay, remember if we go plus 3 to the right, so we go minus 3 to the left, so this number plus 3 is 10, so that will give you 7. Now, so what we do here, if you want to look at it in terms of a general way of looking at it, you're going to have your difference. Okay, let me just grab hold of this. Okay, yeah. Okay, all right, give me 1 second, what's happening there. So when we look at this number pattern, if we consider the 0th term, I say 0th term, okay, is the term before the first term, that gives us 7. So if you want to look at this pattern here, so we can say the nth term, which we start off with un, is equal to the 0th term, okay, plus the difference termed by n. So this is like a formula style of looking at this question. So now let's put in now into here what we've got. So the 0th term, what do you say the 0th term was? What's the value? The 0th term is 7. What was the difference? Difference is 3. And the n is the general term, which means any like term number. And this is giving us now our nth term, which is represented by this formula here. Okay, are we happy with that so far? Now, once we've got our general, once we've got our nth term, what we need to do, we need to test it. Okay, does it work? For example, let's have a go. So what do we say? Say, does it work? Now, what's the first term in our pattern? The first term is 10. 7 is our 0th term. Remember that. So our first term is 10. Second one is, and the third one is, okay, so if I put 3 into my formula here, I should get 16, shouldn't I? Because this rule that we made generates the answers. Yeah? So when I put 3 into here, into what we think is the correct rule, we should get out 16. So we will read n equals 3. So u of 3, the third term should give us what? 16, isn't it? So you have to check that now. So let's get our formula. Our formula says u to the n is equal to 7 plus 3n. Now what is the value of n in this case? What are we putting the value then? 3. So we say then, the third term in our number pattern should be 7 add 3 times by 3. That's n, which is equal to 7 add 9. So the third term of our sequence should give us a value of 16. And we said earlier that that's what we expect to get. So we can say, yes, the rule works. Does it work? Yes. So we can give our rule a tick. Now, once you have a number pattern and you work out what the rule is, we can do lots of things. Number one, we can test whether it works. We can work out what the 10th pattern is rather than you having to add 3 10 times, or the 29th pattern rather than you having to add 3, in this case 29 times, and write it out and then laboriously work it out. You can put 29 straight into the formula and get the answer, for example. Okay, and you can also test whether the number belongs to a pattern. Okay, so what I'm going to do now, I'm going to clear this space up a bit and we're going to move on to the next space. So we know we've worked out the rule. So the rule follows what? So when you want to work out the nth pattern, we need to look at this template here. So this is how we do it. So we're going to work backwards to the 0th term, work out the difference multiplied by the n, which is the term number. Now we've just tested whether the rule works, and it works. Now we're going to do two other things. We're going to work out other term numbers, and we're going to test whether a number belongs to a set or not. Because both are styles of question that you can be asked in examination. But before we do any of that, let's have a go at working out these two missing numbers. So let's carry on here. So the pattern goes up in 3. What's the next number, the missing number? 19. Then we add another 3. What do we get? Well done. So to work out the nth term of a linear pattern, we look at the 0th term and then we add to that the difference time by the n. Okay, that's our like little template formula style of doing it, and then that gives us a nice little rule, and then we test it. So this part here was the testing, and it passed. But we just done that there. Okay, I'm going to get a clean page now. I'm going to copy this formula across, and we're going to do two other styles of question. Okay, and then that will give you the kind of the scope of the kind of question that we could be doing. Okay, actually 3 bits we've got to do. Are we happy with that? Okay, first style of the question you could be asked in examination, saying, so you've worked out the rule. What was our rule, by the way? Can you remind me what the rule was? I've gone to a different page. What was the rule? So we said that our nth term is equal to, what was it? 7 plus 3n, is that right? So that was our nth term. So the question number 1 is, what is the 20th term? In this number sequence. Okay, so what is the 20th term? So what does that mean? So that means that we are looking at our formula. You have U20, 20th term. So we always start with 7 and we add 3 times by the term number. So the number 20 has to go into n first. So 3 times by 20 is 60. So the 20th term of this number sequence will give us 60. And we can do that without having us to write it out and manually add 320 times. Okay, that's what the formula enables us to do. That's the first type of question you can have. Are we happy with that? Okay, here comes the next question. Okay, we need to pause a bit. Okay, so this next type of question again is another examination style question. They said, is 38 a number in the above sequence? So what do we know? We know the formula UN is equal to 7 add 3n. Now we have to start from there. So this 38 here, they're asking, is this a number in the sequence? Meaning, is this an answer to one of the term numbers? So we've got to put for UN for the term number 38. So that's the answer. So they've given us the answer. They're saying, is this one of the answers to the number pattern? So we're going to find out whether that exists. So let's try that then. So 7 plus 3n. So what do we need to do? We need to work out the value of what is the term number that would generate 38 as an answer if it is an answer in this. So let's have a look. So n has been times by 3, we call that the first action. It's been added by 7, it's called the second action. We always move the second action first. So opposite of add 7 is minus 7. So 38 minus 7 will give us what? 31. And then what do we say? Opposite of time by 3 is divide by 3. So 31 divided by 3 will give you 10 and third. Now, remember this. Let's have a look at our answer and see what is our answer saying. So we put the 38 into our rule, and that worked out. To get an answer of 38 in our pattern, we need to have the term number as what? 10 and 1/3. Okay, can we have a term number of 10 and 1/3? Why? Because n has to be what? Whole numbers, linear. Okay, n has to be an integer value. So we could say here quite comfortably now, the number 38 is not in the above number sequence. Okay. So it implies that n equals 10 and 1/3. Okay, but n can only be an integer value. Integer value here meaning a whole value. Okay, are we happy with that? You need to copy that reasoning down. You copied all down in purple. If you haven't copied that now, come get rid of this page now.